This is a Geek Leader podcast, and I'm your host, John Rauda. This show is all about helping us grow as leaders, become better technologists, and improve our lives both at work and at home. I hope you enjoy the show and learn a lot. Hello, world, and welcome to a Geek Leader podcast. I'm your host, John Rauda. Today's sponsor is A2 Hosting. I've been using A2 Hosting solid-state hosting solutions for our website at geekleader.com for many, many years now, and absolutely love their support, their service, and all the features that you get. You get access to cPanel. You get all of the things that you can imagine for a great WordPress experience, including their A2 optimized WordPress, which does extra security checks, extra lockdown. You can lock down your editor file so you can't edit anything inside there. You get alerts whenever there are file changes that are done. You can also do automatic updates, backups, and more with A2 Hosting. So highly recommend it. Go to geekleader.com/A2 to get more information and to sign up for their solid-state, turbocharged speed hosting today. Again, that's at geekleader.com/A2. All right, Geek Leaders. Today on the show, I'm honored to have Robert Cooke. He is the founder and principal architect at 3Forge, which is a New York-based provider of data virtualization and virtualization technology. We're going to talk a lot about data virtualization today, probably more technical based than a lot of our conversations, but we'll also talk about leadership and how Robert got to where he is in his career and all that good stuff. So with all that being said, Robert, welcome to the show.
Thanks for having me, John. Good to be here.
If you don't mind, just tell the audience a little bit about your background and kind of how you got to where you are today and why you founded 3Forge.
Sure, absolutely. So my background, simply put, I've been fascinated by computers my whole life. Long before I even knew what a computer really did, it just seemed like kind of this fascinating topic that I wanted to learn about when I was really young. And then, once I got my first computer, I immediately fell in love. I didn't really have, this is back in the era in the mid 80s, so I didn't have necessarily a lot of peers that knew a lot about computers, but I found that kind of the challenge. You couldn't just go on Google or whatever, but just learning how they work and exploring all that. And then at some point I realized that computers are very math based, and if you solve something really well, it can be reused over and over again. And ironically, I thought, well, it's just a period of time before all the best and smartest mathematicians solve all of the problems on computers, and there'll only be no jobs left. So I better get really good at computers if I want to be one of those people. So I really, really dedicated my life to it. Little would I have known that here we are, 40 years later, 30 years later, and it's 50% of the world seems to know how to code and whatnot. But at the end of the day, I still have that focus of what does it mean to build, the highest quality software possible. So that's really been my life story. I can't remember a time when I wasn't thinking about that. And so that's my background. Now in terms of my professional background, went to Rensselaer Polytechnic up in Albany, New York. I started out, I worked on the West Coast for a little bit, for a few Silicon Valley type companies. And then I moved out to the East Coast where I really got my grounding. I worked at Stearns for a few years. I was a head of infrastructure at a dark pool called Liquidnet. And then after that, I started 3Forge. So that's a very quick background on the, for me.
Awesome. And what is, when you started 3Forge, what need did you see that was in the marketplace or out there in the world that needed to be filled with that company?
Right. So, so the thing was, once I started working for fintech, I realized, first off, the challenges are pretty incredible that they face, and the sorts of things you don't necessarily learn in school. But I think now people are starting to really understand what I mean, which is, as well, the way I like to put it is it's all fun and games until you've been through a merger and acquisition, because at that point, suddenly whatever sort of homogenous IT technology you had, you can throw that out, because now you have two different groups that have come together with different technologies, and you want to try to make a 1 + 1 = 3 scenario. Obviously, mergers and acquisitions isn't the only way that happens, but really what I realized early on was you had very different teams, or different teams solving very similar problems in very different ways. And as I began to manage different groups, and I really did get my feet wet in a lot of different areas. I was working in the compliance area for a period of time. I did high frequency trading. I was running DevOps, et cetera, et cetera. And really, when I looked at it, a lot of the problems you're trying to solve is the same, but they were being approached in a completely different way. And it really brought me back to my roots and asking the basic question of, what does it mean for humans to interact with computers? And I felt that as I was at these fintech companies, I could almost universally persuade someone to focus on what does it mean to build sort of an abstract platform that can connect to lots of different systems and help solve these problems of cutting across different types of technologies and provide a unified solution. At the end of the day, it really wasn't the fintech companies are not pure IT plays. And really what I realized I was trying to do was a pure IT play, solve and build a new type of platform. So at that point in around 2010 is when I decided to focus on that, and 3Forge was born.
Awesome. And when you look at things that fintech, some of the unique problems there, I imagine you're talking about volume and speed and things like that come with the amount of data that travels through.
Right. I call it the 3 V's: volume, velocity, and variety.
Ah, yes.
and all of those, and it's really the triple whammy that makes it a very interesting challenge, because when you talk about volume, I mean, they really are truly huge amounts of data that you're trying to process. I mean, if you look at like market data, which by market data I'll specifically talk about maybe just equities, and I'm just throwing that out as an example. You don't really need to know what that means, but it's just every time the price of a stock changes, that produces a piece of data. And when you add all that up, you're talking billions and billions and billions of events in just a single trading session. And if you really look at it and dissect it enough, you get into the trillions. So the volume of data is huge. It's incredible. And then you talk about the velocity of it. Well, if you just divide, you got 86,400 seconds in a day, and if you divide the trillions of events that take place in a day, the velocity is incredible. And then the real gotcha is the variety, because the same type of data is managed by different groups with different backgrounds and pedigrees, and they're solving the problems in slightly different ways. And I mean, I could talk about very simple things like you might call an order ID an ID with a capital ID, and I might call it an order ID with a lowercase ID. Maybe you decide to take your unique identifier and put a date in it, and I decide to take my identifier and do time date, you do date time. I mean, just little things like that. But when you're trying to deal with massive amounts of very quickly moving data that's also different, that's where the challenge comes in, and that's what 3Forge has really been focusing on.
So how do you, like you talked about acquisition, and I can think back to it. I'm actually going through an acquisition now, and I've also think back to my career. So, probably a decade ago, we purchased I worked for an ISP, and we purchased another ISP that was smaller. And I remember I was part of the team that was migrating the data for their customer records, and just, what you're talking about with order ID and customer ID. And, for an ISP, you have like the service location and the other, and their billing locations. And getting all that data kind of correlated was ridiculous. And
it is. Yes.
Yeah, it's just ridiculous. Like I remember looking at some of the terrible data that was there. And also when we got into map data, so like GIS, and then you're looking at, how was a map drawn at certain time periods? Because if you take an old map, they might not have used GPS coordinates to draw the map. They probably used something different. AutoCAD or something to that effect, and just drew something out. And then you try to put it into Esri, and you're looking at two totally different types of data formats, and it gets really complicated really quickly.
It does, yeah. And one thing I've learned, and I will reassure your listeners of right now, is that a lot of times we come in and we'll talk to groups or companies or different prospects, and they're under the impression that the way they've done it is so bad and so terrible and it's just so messy that it's unsolvable. But one thing I will say, again, to rest assure everyone, is that it's actually no worse than all the other companies out there. You know what I mean? It's just everyone we go to. I mean, this is the reality of it. And it's, each group does it a slightly different way, and so you end up with this complex problem. But that difference is actually, ironically, it's very common. these differences are universal. And so we at some point, and by the way, I think an interesting piece of history is the data lake and the data ocean, because for a period of time it was, and not that there isn't value in the data lakes and data oceans and whatever names you prefer, whatever body of water you prefer. The concept is let's just take all the data and normalize it and get it into one place. And it's an interesting approach, and it does work in certain cases. I found it works when maybe you're trying to meet a very well very well outlined like regulatory report or something, or maybe in the case of you as an ISP, company A, company B merge, you come up with you sit back and you say, so we'll call that A and B, and then you say, and we want data to look like C. This is the output of that. Okay, so now you can do this one-time normalization. But the problem is with the data lake, data ocean approach is that as systems keep evolving and mergers and acquisitions take place, and I really shouldn't focus on too much on mergers and acquisitions, because it can be simply just changing roadmaps. And so you end up with this ever evolving schema, if you will. And so we ultimately arrived at this concept that we call leave the data where it is, which is you leave the data sitting in the various locations in the formats, in their original formats. And again, maybe you do use the data lake for certain parts, but then basically you connect our software to all of these pieces and you do the normalization in there. And then on demand, we're basically normalizing that. And especially is when you start to get into these sort of highly evolving, highly changing technologies. This is really, in my opinion, the only way to do it. Because otherwise, if you just try to copy all the data from point A to point B, now you've actually just got double the problem to worry about.
Well, how do you tackle the issue of speed then if you're leaving it where it was? Are you like adding new indexes? Are you rehashing are you moving things to a NoSQL type environment? What's the...
Right. So it's a very interesting question. The way I look at it is, first off, I don't think it's any secret that there are many, many different database technologies. And these database technologies usually exist for a good reason. A lot of them anyways. And, a simple example would be there's columnar databases that use columnar indexes. So they're very good at storing time series information. You have NoSQL databases that are good at storing documents so that you can have arbitrary information and look that up. And then you have databases that are designed for storing binary voice recordings, things along those lines, and those are designed to basically tackle a certain set of problem. You've got SQL databases which are designed to store structured data, and I can go on. But each one of these databases, and you can even further subdivide that. You've got certain types of databases that are normalized, yet they're more designed for historical data. The point is, people have worked very hard to create databases that solve a particular set of problem. And so what we're saying is, when you leave the data where it is, you're leveraging that unique technology that was built to solve that particular type of problem. What's nearly impossible is to say we're going to create a data lake which actually has all the attributes and functions of any technology out there, that it can meet the needs of a historical database, real-time database, columnar database, time series database, et cetera, et cetera. Yeah. So the way we look at it when it comes to the speed and performance is, now you may end up duplicating or horizontally scaling technology, but by leveraging technology best suited for a particular problem, that actually gives you the best performance.
So, okay, I get you. So, can you give me an example of like where you would put two different systems together to kind of pull data? Because a lot of the value you get with analytics and different pieces of data is being able to combine information from system A and system B and get some new insight to how you can market to customer C.
Sure, yeah, and so it always becomes, I will call it, a fun architectural conversation as to how you want to design this. So let's say we've got two pieces of data. We've got trading information and we've got account information. Let's say the account information has like geolocation, like where the office, the headquarters is located. And then the trading information has things like volumes and frequency of trades of people executing orders.
Okay.
And those are sitting in two different databases. Now, what we would say in this case is, as an example, what one approach we might take would be, basically you would take the interesting or most important relevant information from those two systems, bring those together either in memory or into our columnar store database. You would join that, and then you can run analytics off of that. But then the thing is, after you've run this analytics, now you usually want to drill in to see the more interesting pieces. And that's where we would say you go back to the original source. So for example, we join all the data together, and then we join these two sets of data together, and then we realize that we're seeing the highest volume of trading for cryptocurrency is coming out of Singapore. I don't know, just picking that, right? Now the next, so you can do that by joining those two data sets. You don't need all the data to figure that out. Now that you've realized that, well, what makes Singapore so interesting? Now, this is where you leave the data where it is philosophy comes in, because now let's say you literally would click on Singapore or follow some sort of workflow, and then it would actually go and query those two underlying stores specifically for the Singapore data, bring that up, and now you can start to look at that. And maybe you need to drill down even further and go further and further back until you get to the original piece of information that's interesting. And so it's that ability to drill in, to get to the individual records that you need to make the sort of analytics, I would say, complete.
Okay. And how have you seen this change over the past, let's say, a few years, when we've had a significant increase in I guess trading in general when it comes to like crypto and things like that have happened? And it's I don't know, I just got back from vacation. Okay, I went to Turks and Caicos with family, a whole bunch of people, and even there people are talking about trading. We had 19 of us, and they're talking about like stock trading and crypto trading, and it's things that I would never have had those conversations 3 years ago with my family, and now they're all it seems like it's top of mind and things that people are interested in. And I'm guessing you've seen a lot of volume, a lot of uptick in all this in things in the past couple of years, right?
Yeah, absolutely. Well, I mean, one thing that technology has done, I mean, it's so ubiquitous now, and is that it's obviously humans are far more connected to technology than they ever have been, and I don't see there's any reason for that trend to stop. But
Right.
as that happens, and by the way, as machine learning and AI, those grow and continue to produce data, that just means there's more and more data out there, and there's more and more people interested in that. So I would say that that's certainly a trend. Is again, there are more people that I guess are sophisticated enough to be involved in the financial markets and participating in that. And absolutely, we've seen that. Does that answer the question?
Yeah, I think so. I think and I'm guessing there's a lot of correlation with people. We've gone through this great resignation, as they're calling it, where lots of people have kind of moved and become working remotely, and a lot of people have started up startups now too, trying to capitalize on some of this change that's going on post-pandemic, or if we're still in the pandemic, I don't know. And trying to get data. And I was talking to a neighbor of mine who actually has a business where he uses a lot of Google AI to run analytics that he's pulling off of Facebook to do targeted marketing and all kinds of interesting pieces there. And I'm guessing you've seen an uptick of that kind of stuff too, outside of just fintech.
Yeah, absolutely. I mean, the whole thing is, and I suppose the other part of the trend I should talk about here is one, that the amount of data is growing as, like I said before, users have more access to this and they become more sophisticated. But the other thing that's happening too, I think, is that companies are realizing en masse, and you mentioned Facebook. Did you mention? You said pulling data from Facebook and using Google AI. Yeah, and Facebook was, I think, one of the first to realize this, is that all of this data, which was originally thought of as a cost, is actually an asset. And by that, what I mean is that, in the beginning, it was like, oh, we have to store all this data for 7 years for compliance reasons. And you have to have hard drives, and you have to have hosting, and you have to pay these cloud, et cetera, et cetera. And that's all true. But the value of that data has moved on the balance sheet from a cost to an asset. And so, what he's doing, what your neighbor's doing, is the same thing that these large companies internally are starting to realize and just starting to touch on. Because the fact is, at the end of the day, the reason Google, or I'm sorry, Facebook's where they're at is because they have, for better or worse, they've profiled their user base. And the thing is, these large financial institutions, and financial technology companies have that ability, and they're starting to take advantage of that. But again, that all means to take data from a variety of different systems and bring that together. And I cannot overstate how important that is, but how complex it is, because you just have data in different varieties sitting in different systems. And it's like the keys are sitting there. The information is sitting inside their four walls. It's just, how do you bring that together? And another thing I'll mention too is that there's really two parts to this. One is, how do you mine that data so that you can better serve your customers in the long run? But then there's also, how can you access that data to better serve your customers in the immediate? And by that I mean, I don't, if your experience is like mine, it seems like whenever I call up any company to ask for help, it's a very long wait line. They ask you for lots of information, then you get transferred to another group. They ask you for the same information, you get transferred to another group, and sorry, it just takes a long time to get to where you need to be. I think one of the most striking things we've helped our customers do, 3Forge has helped their customers do, is provide their customers with very, very fast, I would call it high touch support, meaning that when you call into the desk of the bank, and you have an account and you trade many different assets, you can call up, you can ask a question, and the support or the sales trader can immediately have access to all of the relevant information and can basically tell where your positions are at, and basically take actions on behalf of the customer. And this becomes very, very important in fast moving markets. But I believe the same thing can apply to just about any industry. I have to admit, I wish I could call up my ISP as an example. You brought that up before, and just make these changes right away without having to go through,
Yeah, I think about the medical world just in general, because it seems like every time I go to a doctor, I have to fill out the exact same form that I filled out, 2 weeks ago. And even I tore my ACL a few months ago, and I had to go through physical therapy. And no joke, every time I went to the doctor, I had to use. They had an app now, which is nice. I don't have to use pen and paper. But I'm seriously answering the exact same questions that I answered last time, and there's no way to push a button and say populate from last time or anything like that.
And to a degree, they use HIPAA as a reason, but that certainly doesn't. I think that's a bit overreaching to say. I know exactly what you mean. And yes, there's a lot of
doctor. It's the same form I filled out last time. Why am I doing it again?
Exactly. There is no need to do that, right? I guess we can get into why different industries seem to be more ahead of other industries. I personally look at it. I've had this view for quite a while now that fintech is actually, computers. I think in the beginning, yes, they were used for the military a lot, but one of the fundamental things computers started out in was accounting and managing ledgers and finance. And so in a way, the fintech, the tier one banks of the world have been dealing with these problems and how to better serve their customers longer than anyone else. And whether they're as fast paced or this or that, I'm not going to get into that debate. But at the end of the day, they've been dealing with this problem for a long time. And I think you can look at how fintech has behaved, the problems and challenges they've seen, and how they've tried to at least solve some of these issues. And I think other industries could take a lesson from that. I think the medical field, the health industry is a perfect example of that, where yes, they have a lot of room for improvement.
I never really thought about that before, but when you think about the name of a computer, it's really, computing data, which probably went back to counting money.
Right. Yes. Right. Exactly. Yes, it was. That was one of the first things it was used for. International business machine, was to basically operate.
Yeah. I know when I got first excited about computers is because my dad worked at a bank. This is when I was probably 5 years ago or longer, and he was a computer operator. And back then it was a bunch of punch cards that,
Right.
you'd put in order and stick in there. And that fascinated me. I was interested in
Mhm.
that. And that was the only industry at the time that I remember using a computer.
Yes. Yeah. It is. It's actually amazing to see. And yeah, maybe I'll change topics here now that you mentioned punch cards. But it's actually amazing to see the evolution of computing. Um, which, at least in my very simplistic view, I look at it as originally you had this hardware solution that had to be manually, basically configured each time, and they physically tried to solve the problem. And then you move to punch cards, and then at
Mm-hmm.
some point people realize, well, computing time is valuable, and compilers can help with that. And then you move a little bit further, and you realize operating systems can save a lot of headache. And then at some point, people realized, well, instead of having to read and write from disk and write that code every single time, we can use databases. And then we got operating systems with graphical user interfaces like Windows and Apple and things along those lines. X Windows, which was my favorite at the time. Anyways, but what I find interesting is I feel like history kind of just took a pause at that point, where it seems as though we're almost caught in a loop. And what I mean by that is we now have figured out how to use operating systems, how to use databases, how to scale these things out, how to build the cloud, et cetera, et cetera. But what I've always believed, and what 3Forge is focused on, is what does that next layer look like? And I believe that there is what I would call a data virtualization layer, a virtualization layer that sits on top of all of this infrastructure. And it provides everything humans need to interact with that in a holistic way. And so that's really what our product has been about. And when I say humans interacting with computers, I've actually broken it down into three categories. And believe it or not, after thinking about this long enough, these three categories cover just about everything that you need in order to interact with data. And one is, you need to be able to ask a question to a computer and get a response back right away. The analogy I make is running a search on Google.
Mm-hmm.
You need to have information pushed to you in real time for important events. The analogy I make is getting an email. And you need to be able to enter data into a computer. And actually, that's it. Those are the three things you need. And so that's what we've basically broken everything we've done into those three buckets and solved for those three things. And data virtualization, all these other things come out of that.
Wow. When you break it down, it seems so simple.
It does, right? Yeah. But I think, but that's what I love about computers, because it's not like I just woke up and said, well, this is it. But what it was tackling problem after problem from customers on how to solve these things. And the thing is, you have to solve these problems generic. Well, I guess you have two paths. You can either say, which frankly I think most vendors do, which is, okay, there's a problem, we're going to go out and run a bunch of code that solves that exact problem. That doesn't attract me. Instead, I think you can take lots of problems, and then you can look for the commonality in those problems, distill it down, and solve for that. And that's what makes computers so awesome, is because it's that latter one that always wins. Again, there was a point where people wrote database would write write data to disk to tape manually, read and write. And someone at some point, some smart people said, wait a second, we can create a database. And instead of having to worry about reading and writing and physically managing ACID, if you will, that's an acronym for what databases do. Instead of having to manage that manually, we can just write software that does that, and then you focus on that. So those people that wrote the original databases, they took a whole set of small problems and they found a common solution to it. So anyways, that's what we've done. I mean, we've really looked at what does it mean to build software that allows humans to interact with computers. We've distilled it down to these three things. And then we've gone to town on trying to solve each one of those best we can.
Awesome. And what is the the core like when you look at asking a question, and I've seen, this iteration happen, obviously a lot in my lifetime. Before you had, keyboards where you would type in, and now we have Siri. That's my kids thought, Siri's like a person somewhere else on a phone call. You're, they don't realize you're talking to a computer.
Poor
It's like,
kids
hey,
of this
Siri.
generation. I never thought about that. Oh my gosh. They don't even
Yeah.
know it's a real human anymore. Okay. Right.
Yeah. It's crazy, isn't it?
Sorry. What was the question? I didn't mean to distract. Yeah.
So yeah, it's just, you get into that, like, that kids just today, you're all just asking a question, getting input, and getting notifications back.
Mhm.
And when you break it out to these simple forms, what's next? And what's the next way? Is it going to, you have Neuralink, where potentially where you don't even ask the question, it's just, you just think it?
I can't predict that too much. I think when it comes to the actual human user input, the HUI as we call it, that's evolving and changing. And yeah, I mean, who knows? I mean, there's technology out there that now can take camera and pull in gestures and use gestures to do these things, et cetera, et cetera. So what I actually have, I would say, devoted my life to is not what it means, not how the question can be asked, but how to answer it. And so what I mean by that is whether your child is using Siri or typing it into Google or using a hand gesture or whatever it happens to be, ultimately that is getting converted. That is getting converted into some sort of textual representation. At least I believe it will always be that way. It's certainly that way right now. And now the thing is, how do you take that question and farm that out and get a response quickly? And so behind the scenes, we have two things. One, you have to have a data virtualization layer so that you can access many different types of data simultaneously, and then you have entitlements and all that stuff. But another thing is a thing we focused on, which is what we call cascading queries. So what that means is I'll try to think of a good example question. What is the next time a train, I can take the subway to the nearest McDonald's? Now that's a cascading query, because first off, you need to talk to one system to find out where the nearest McDonald's is. So you go to that system, you find out where the nearest McDonald's is based on your local geolocation. And now you get this database of ranking of closest McDonald's. By the way, I'm not a sponsor of McDonald's or anything. And then so now you've got this ranking of all the McDonald's, and now you go back to another system and you ask a follow-up question, which is, what's the train schedule like from where the individual is located to the McDonald's? And now you've got the train schedule, you get the answer, and now you can go back to the user. Now, here's the thing. We have technology that does that today. We all know this, that you can type in, your local retail shop and it will tell you the train schedule. But behind the scenes, we're talking hundreds of millions, billions of dollars being spent manually writing code that does these cascading queries. And I think a lot of these companies who solved it don't even realize they're really doing cascading queries, or have necessarily distilled down the concept. So what we focused on is, how can you take a complex question, and I'll give a real world in finance, which is, believe it or not, this is a complicated question, the answer, which is, how much money does a client have open in the market right now? And I'll explain why that's a tough question to answer. Let's say you, John, are trading a bunch of stocks, and some stocks are, in one currency, other stocks are in another currency. Maybe you're trading options as well. And so that's going to a completely different desk. So you submit these orders to your broker dealer, and then eventually they make their way out to the market. Now, when they're sitting in the market, that's what I mean by an open order. It means it could be filled. And when it gets filled, you're now responsible for either buying or selling the physical asset you're talking about. But to answer that question, you actually need to go to maybe dozens of different systems in order to answer that simple question. In our largest case, we've basically integrated over 50 different systems in order to answer that simple question. Now, the question seems simple, but the answer is extremely difficult. So my point is, I can't really tell you exactly the ergonomics of what the user input will look like in a few years, but I can tell you that being able to do cascading query where a question comes in and that ends up going and hitting, and you take the answer from one system and you use that to formulate the next question. And maybe I didn't explain that well, but this is part of the cascading query thing is you ask a question to one system, and based on the answer you get from that system, you can now automatically ask another question to a different system. And you keep doing that until you ultimately get to the answer you need, and then you can respond to the customer.
Yeah. And actually, if you take your original example of McDonald's, you can break it down even further because the first question is, where are you?
Exactly. And as I was going through it, I'm like, yeah, I would have that up.
So really, you're taking a cascading query and expanding it even further. But no, yeah, it makes perfect sense.
Exactly. Yeah.
But what's even better than that is figuring out when you don't even know the question to ask.
Mm-hmm.
Like I go back to thinking about in fintech. My wife works in she still works in fintech, but she has pretty much her whole career. And that's the first time I've ever heard of A/B marketing was back in fintech and trying to figure out different things. And they were looking at all different categories of things to see what would increase the likelihood of someone getting a loan of this sort or that sort. And then even before that, it was insurance and looking at actuaries and things like that, and figuring out all kinds of how long this person would live and all that good data. And when you put all that together, it's like sometimes you don't even realize like that this thing is a factor. And I remember one of the things that they found out, like a certain shade of green was a factor. We always thought green button, red button, didn't matter. But no, it's a shade of green button that matters. So like even understanding like the nuances of what thing do we need to be asking to figure out what the next question is an important layer that's, I think could really get value out of other companies that are ripe for disruption.
Right. I mean, I feel like we could talk about this, there's so many different ways this can be applied. We could talk about this for a long time. Basically what you're touching on too is know your customer. How do you really know your customer? And this actually gets into the same thing. You take the answers from one and you ask the next, but I can't overemphasize the problem is, and why software is the $1 trillion industry it is because this is being manually solved every time, instead of thinking about it holistically, which is what is it we're really doing? Because the thing is, know your customer, and most of these solutions that I've seen, and we're then sitting on top of these, so I know fairly well how these are working behind the scenes. Is it's literally large volumes of code that are solving for very, very specific things. And based on that, go do this and run this batch job, et cetera, et cetera. And honestly, that's why sometimes these things like know your customer, although it's gotten more streamlined, but definitely talking about what you're alluding to before around the marketing, sometimes these are week-long, month-long batch jobs in order to bring all this together to give you the information you want. When in a more fast-paced moving world, being able to respond better and faster for marketing is important.
Definitely.
And so being able to build and configure these systems quickly and efficiently and change them, I think is an important thing and gives people a competitive advantage.
Yeah, and I go back to, this is a decade or more ago. They used to run like A/B tests for, a week or 2 weeks and then get the data, and somebody would analyze it and figure out what changes to make and then change it. And then they ended up writing a system that would automatically pick like the winners and have the winners compete and continuously battle, almost autonomously, and always choose the winners, based off different sets. And they could add in different demographics. Like originally it was, time of day, then it was time of day and browser type. Then it was age of person, time of day, browser type. Then it was whatever data they can suck in from Facebook, exponentially grew. And it's kind of cool to see how those things evolve over time and how speed does play an important role in that.
Yeah. And then as you start to bring in these larger sets of data, now you're looking for how does the data actually correlate? I mean, the beauty is once you have the answer, now it's much better you can now extrapolate and figure out what that correlation is so that you can then, expand to larger audiences, et cetera. Yeah.
Yeah, definitely. Well, Robert, I feel like we could talk about this and geek out on this forever.
We could.
But tell people how they can find out more about you and 3Forge and learn more about data virtualization and the things that you guys are doing.
Yeah, absolutely. Well, our website is 3forge.com. That's the number 3, FORGE.com. You can always email us at info@3forge.com. That's INFO at 3forge.com. We're constantly posting on our LinkedIn. So we have a LinkedIn account at 3Forge, plus all the other social media as well. But really, the LinkedIn is where we do almost daily updates to the new types of systems we're adapting to, the new sorts of features we have out, any sort of news, et cetera, et cetera. And also, we recently opened an office in Singapore. We also have an office in the UK. So, if you're in those regions, you can definitely look us up there as well.
Absolutely. And I'll link all that up in the show notes too, including the 3Forge LinkedIn page, which has all your articles and things like that you're posting right now, so that people can find that if they just go to geekleader.com and link through that way as well. Robert, thanks for taking the time and talking to us and explaining some of this data virtualization and the things that you guys are working on.
Absolutely. Yeah. Thank you, John.
If you enjoyed that episode, please leave a rating and review in Apple Podcasts. I'd greatly appreciate that. And also, don't forget to check out merch. We have some T-shirts that I've designed that are on at geekleader.com. You can click on the merchandise section there and check that out. And also, don't forget about the books from our guests. So if you like this guest and other guests that have written books, please go ahead and check that out at geekleader.com. I would greatly appreciate it, and I'm sure they would too.